Bismillah ar-Rahman ar-Rahim. June 23, 43 variant and complete mechanics paper. We are going to start. Question number 1. He mentioned there are two particles. One particle is P and one particle is Q. So situation is what we have. So this is a 0.1 kilogram. This is a 0.4 kilogram. P particle and Q particle. Situation is what? And he mentioned here this before collision, after collision criteria. You know it very well. So smooth means friction is not there, and P is thrown speed of 4. So it means this speed is 4, this one, whereas Q is 0 speed. And he mentioned that P collide, okay, and speed equal after collision. So and he said possible values. So what is the possible values? So two options are there. One option, if a lighter particle hit with a heavy particle, so maybe they move in the same direction. Second option, a lighter particle with a heavy particle, so lighter particle after hitting will rebounce. Okay, will come back. So this is the second option. So we have to discuss both ideas. So let's try to do the first one. A coordinate situation number 1, before collision, after collision. So formula, you know, M1, U1 plus M2, U2 is equal to M1, V1 plus M2, V2. And let's discuss the first option. Both are moving with the speed of V rightwards. Okay, so let's discuss what is the formula, mass 0.1 and speed 4. So I'm getting here 0.1 into 4 plus 0, and here 0.1 into V, 0.4 into V. And I got 0.4, this 0.5 V. It divides and I get answer 4/5 meter per second. So this is a first situation. We have done it. So let's talk about second situation. Second situation, criteria diagram is same. Okay, the thing is only one thing important. And what is that? Look at show you. And that is possibility of second one, rebouncing. Lighter particles sometimes hits and come back. So this is a point I'm going to discuss. And do you know, students, we have discussed this one before. Whenever you know, this observer's eye example, okay, when particle going away from observer velocity positive, coming backward velocity negative. So as it is coming back to observer velocity negative, rest same. So I'm copying the formula from top once again. So one only common point, important point, mass into V, this 0, but here you will put negative V. So 0.1 into negative V and 0.4 into V. And here I get a negative 0.1 V and positive 0.4 V. Finally, I got 0.3 V. And here I got 0.4. And when it will go down, so I will get what? 4/3 meter per second. So we have two situations. I hope so. The concept of the question is completely over. We have now, students, a car of mass 1500 kilogram. Best technique when you do this kind of paper mechanics, either you write data or you mark like this. What is the mass of the car? Mass of the car is 1500. And trailer, the mass is naturally, mass of trailer is m kilogram. And horizontal road and the car trailer are connected tow bar, and there's friction force acting on the car. So this is called friction on car is capital F, and friction on car and trailer is 200 newtons. Driving force acting on an engine is 200. So there's a force acting on a car, you can say, is a 3200, and acceleration is 1.25, and tension the tow bar is 300, and we'll find two. So this is called data writing. Two choices, right? Like this, the way I mark, or you can write separate writing, no issue. So let's try to do the question. Bismillah ar-Rahman ar-Rahim. Okay, so this, let's say car, and there's a trailer, okay, and so this is applied force. This is a applied force, and you know, attention in the tow bar always in a rod or in a string always towards each other. And luckily both are equal given, and they are equals to how much? They are equals to 300. Okay, and now he said friction on a car is a capital F. So FC equal to capital F, and FT is equals to 200. Okay, I think all data is mentioned, and I think I can start a question. One equation I'll make for the car, and one equation I will make for the trailer. Okay, what is the basic formula we use? Net force is equals to MA. And same here, net force is equals to MA. We'll talk about a car, so three forces acting on it. You can see here. So one force acting is capital F, FC minus tension equals to MA. So F is what? 3200. Friction in the car is capital F. Tension is a 3 in a 300. Mass is 1500, and acceleration we have given as well 1.25. And it's matter of F I'll bring on the other side, and this everything on the other end. So 3200 minus 300 and minus 1500 times to 1.25 equal to capital F. Okay, so now I'm going to just type in calculator, and let me check. One this one and 1.25. My answer is turned to be is 1025 newtons. I believe the idea is nothing hard. Same story, I will apply this on these three forces. So tension is because system is going rightwards. I'll start from tension because it's biggest force I consider here. So tension minus friction and is equals to MA. So tension is a 300, friction is a 200, mass unknown, and acceleration 1.25. And here I got 100, and divide by 1.25 will give us a mass. So 100 divided by 1.25, and I got a 80 kilograms. I hope so. The concept is very clear, and the question is completely over. Question number 3, students, we have. And before I start this question, I want to give some extra knowledge. It's a very, very important that I want to discuss here. Let's say whenever this is a, let's say, a string we have, and we have a ring inside. So if lengths are equal, that is definitely tensions are equals to each other. But for your knowledge, extra knowledge, if one string is longer, one smaller, even then if the ring is there, so tension will be again equals to each other. Why? Because string can slip through it and can manage it. But if I have a bead, this is a ring. This I talk about a ring. This I talk about a ring. But if we have a bead, okay, same situation, bead comes. Bead means like a particle, the string cannot slip. In this option, here tension 1, here tension 2, they are different from each other unless if lengths are equal and even bead mentioned there, then tension are equals to each other. So look it down now. This is a ring, and the string is like that. I think you got a point. So now, students, that is why tension is here and tension is here are equals to each other. The logic is very clear. The ring. This is clear. Now, students, if I show the components, this is one component acting upwards and one component acting this way. And because when two lines are parallel, a line cut this way, if this is a 60 degree, so this 60 degree. Okay. So that is why the 60 is coming here. So this is 60 Newton degree. So this becomes T cos 60, and this becomes T sine 60. Whereas this T has a no component breaking because it is a parallel acting to the x-axis. And what about this 60 degree, 90 degree, and what this angle, third one, in a triangle? I talk about this triangle. So it is 100% 30 degree. If I make a straight line, it is a 180 degree. And out of this is a 90 degree, 90, 30, 120. And what left behind is this. This becomes 60. So one force acting this way and one force acting this way. And common sense, this is a 60 degree, this is x cos 60, this is x sine 60. And mass of the ring is 0.2 into 10, so 2 Newton force acting downwards. I hope so. You understood how I resolve forces. Now, nothing hard. Further, so horizontally, or horizontal component braking and vertical. So when I talk about horizontal, this acting rightwards, these two acting leftwards. So I can say here x cos 60 is equals to t plus t sine 60. So this is done. Now let these two forces acting upward and this downwards. So I can say here t cos 60 plus x sine 60 and equals to 2. One more interesting part I just tell you, if some student don't take 60 here, they take here 30. And for your knowledge, this 30, then this could be naturally t cos t. In that situation, this become t cos 30. For your knowledge, cos 30 and sin 60, they are exactly same. So this is another idea I just want to deliver to you. Now I have to solve them simultaneously. So this cos 60 will divide both. I will want to make x alone. When it divides, so t over cos 60 comes separate, and t sine 60 over cos 60 comes separate. And if we check in calculator, 1 over cos 60 is 2t. And sine over cos become 10, and that become root 3t. So this is the x value going to be go there on the other part. So let's plug in the values and get the answer. So t cos 60, I'm not changing. Whereas x, in the place of x, I'm copying 2t plus root 3t, and outside sine 60 multiply is equals to 2. Now, students, I can take this t common out. When I take t common out, students, what is left here? Cos 60 plus. In the bracket, I have in the bracket 2 plus root 3 left, and time to sine 60. And the bracket close equal to 2. Now I want to bring it whole in denominator. I will get my answer and check it. Cos 60. Now I believe if you will type this in calculator and you will get your answer. Wait a minute. And let me check my own values when I check it. Wait a minute, students. This is a cos 60 times. Okay, so this answers turn to be tension equal to 0.535898. After rounding 3D or 3SF, so I can say here this is 0.536 newtons. But if I want to use this answer there, I will use exact answer in the place there. So I will make it like this, students. So x is equals to 2 plus root 3 and t value 0.535898. And when I multiply 2 plus root 3, so I'm going to write my final answer, which came sharp 2 newtons. Sharp 2. Okay, I hope so. The concept of the question is clear, especially the criteria, the rules on the top. You understood as well. So let's go for next question. Question number 4 we have now. A mass of 1500 kilogram, just mention here mass. And a straight horizontal road, direction is A to B, is traveling. So I think I just mentioned A to B. Rough diagram is very, very important to make it. Okay. And it said speed of A 20 and B 25. So speed at A 20. Speed of B is 25. And power of the lorry is the constant frictional force throughout 6,000 newtons. Acceleration of lorry is at B is 0.5 times than acceleration at A. Repeat. Acceleration at B is means like this is a 0.5 time to acceleration at A. So this connection is also very important. Okay, and it means this, let's say this is acceleration at B. So acceleration at A is acceleration, let's say A, okay, no problem, or AA, no problem at all. Okay, let's talk about next plan. Let's show the power of engine is this much. So what is the basic criteria, student, we use? This kind of question, we will make two equation. Net force equals to MA. Okay, I guess I give example. When a lorry is going, for example, this is lorry is going here rightwards, applied force, frictional force. So I can say capital F minus small f is equals to MA. So just a minute, copy and paste. We are going to do two things. One, I will talk about A, and one I talk about B. So what is F? Basically, formula power is equals to F into V. If I bring this V down, so I got the power by speed minus friction is equals to MA. Same story here. So we got two equations. Power is unknown and speed is, the first situation is 20. Friction throughout 6,000. Mass is 15,000. Acceleration is, I'm writing A. Okay. So what other situations, students, we have? Power again unknown. Speed is 25 this time at B. And friction is 6,000. Mass is 15,000. And here I'm writing acceleration of B. Acceleration of B is basically equals to half times 2 acceleration A. Now, see, you can eliminate acceleration A from both equation. We'll get our answer. And what is a planning in my mind? If I divide them, okay, I have two options. I have two options, try to make subject, but if I divide them, so I'm writing here equation number 1, equation number 2. Equation 1 divided by equation 2. What happens? Let's see, students. So this left-hand side value, copy, or I copy the whole thing better. Copy, paste. And the same way I copy this equation full and paste here. Basically, I'm dividing them. So look, both equal sign I'm erasing. I'm putting in the middle and division and division. So basically what I'm doing, students, I'm dividing both. And I hope so you got a point. And when I divide left equation with the left and right equation, right part with the right part. So basically this fully cancel out, acceleration cancel out, and 1 over half, I repeat, 1 over half gives you 2. So it means I get a finally, I'm getting what here, students? So P over 20 minus 6,000 over P over 25 minus 6,000 equals to 2. Now this will cross multiply. So P over 20 minus 6,000 equals to 2P over 25 minus 12,000. Okay. So students, I'm going to bring it this side and this on the other side. So I get out of 12,000, I got a 6,000 left side, and this will go there, and that PP common out. When a P common out, 2 over 25 minus 1 over 20, and which I'm typing in calculator and divide on left hand side. So 6,000 and divided by 2 over 25 minus 1 over 20. And my answer is coming 20,000 watt. Sorry, 200,000, sorry, 200,000 watt. So finally I can write, I got a 200 kilowatt. So proved, I have done it, but my space problem now. So I'm writing the second part below. It's a find acceleration of the lorry when it's a traveling of 20. So I'm writing it now here. Basically, what's same formula I'm going to use here? Same formula I'm using here, students. Same formula. So let's try to do it here. So basically 200 and three more zeros I'm writing. And our speed is mentioned here. That means speed is 20, 20. Find out the acceleration. So speed is 20, friction is 6,000, mass 15,000, and acceleration is my task. So let me type in calculator and minus 6,000 and divide by 15,000. I'm getting 4/15 meter per second square. Okay, or in decimals. So 0.267 meter per second square is my answer for part number A. So this is more lengthy, but okay, anyway, I hope so you got a point. Let's talk about the question below. A lorry begins to ascend a hill of 1 degree horizontal. It means is a situation is like this. You see, every time I make a diagram, this applied force is equal to power by V, and there's a frictional force, and this is a mg sine theta. So basically, and here's a steady speed. Steady speed means acceleration is 0. Net force equals to ma. So P over V minus friction minus mg sine theta is equals to 0 because acceleration is 0 steady speed. Because it is given steady speed. That is why. So power is remain same, he said, 200,000, and speed is our task. Friction is remain same, 6,000. Okay, and I bring this both values right side. I'm saving my time. So I got equal and 15,000, gravity 10, and theta is 1 degree. And now, student, what I will do, bring V on the other end. This will go down, and I will get my answer. I'm going to show you. 200 and 1,000 divided by what? Divided by 6,000 minus 15,000, one more zero, into sine 1 degree. And now I'm going to type in calculator, and my answer is turns to be, 1 minute, please. Okay, I'm typing it now in calculator. And my answer is 23.2 meter per second. I hope so. The concept is completely clear of the whole question. So data writing and diagram is very, very important. Question number 5, P starts from rest. So this kind of thing, whenever we have to write data start from rest from O. This means when time is 0, distance, no distance traveled, and rest mean velocity is 0 as well. Okay, this data is very important. Acceleration given by him is this. So k t2 power half. Okay, and velocity is given. He given the velocity is at time 9. When time is 9 seconds, velocity is 1.8. And we have to show this link. How we can show this connection? Have a look. First of all, there's velocity given, so I have to integrate. We have a 3-level, students: displacement, next level if velocity, next level is acceleration. If you want to go 1 level up, so we differentiate. If you want one level up, we have to differentiate. And if I want to go 1 level down, so integrate. And if I want to come down, integrate. So we are currently on a level of acceleration, and we need a velocity. So I have to integrate. So V is equals to integral sine k power this one. So what is the way of integration? Increase a power by 1 and divide by same and plus c. Okay, first of all, we want to get rid of c. How we can get rid of c? We put this data to get rid of c. So we'll say that put time is 0, v 0. When a 0 comes and 0 here comes, so c value becomes 0. So we got this equation turned to b. So this 1 over 3 by 2 will turn to be 2 over 3. So I got a 2 over 3 2 over 3, k times 2 to the power 3 by 2. Now, student, I will use this data and plug it in there. So put now t is equals to 9 and v is equals to 1.8. So 1.8 equals to 2 by 3k as it is, and time 9 to power 3 by 2. 54 divided by 3, it tends to be 18. So this is 18. So when I got 18 here, and 18 goes down, so k value becomes 0.1. So this he was asking us. So we have done it. Let's go for next part. He's saying this is a question we use for more than t9. Okay, this is a question we have used 0 till 9, and this equation used after 9. Show distance traveled with the first 9 seconds. Let me write distance from 9 seconds is deal as an equal sign. Okay, 1/10 of what? Distance traveled between 9 and 18. So 9 till 18. So this is my task. So best technique, I will find both distances. So first of all, I want to find distance from here. And we know if we are on the velocity level, and if I need a distance, so I will integrate once again this expression, sorry. So I'm going to integrate here. 2 over 3, and this value, if I multiply there, so 2 over 3 into 0.1, I get a 1 over 15. So this I'm replacing 1 over 15. How come? When I plug in 0.1 here, so I get a 1 over 15 t to power 3 by 2. This is data for 0 to 9 seconds. Okay, so let's talk about integrate. When I integrate, student, what will happen? Here s integral sign, write 1 of 15 inside or outside, no problem at all. Increase the power by 1, so I got a 5 over 2 divided by same and plus c. Okay, or plug c, not required. We can write directly 0 to 9, and plus c also write, not wrong at all. So 0 to 9, and I have this one already. So so it is 1 over 15 and times 2 over 5. So this turned to be 2 over 75, and now plug in 9 to power 5 by 2 minus 0 to power 5 by 2. And you know it very well, 9 to power 5 over 2, and I get here distance from 0 to 9 seconds, 6.48 meters. So this is done. So first 9-second distance, I got it 6.48. And now I'm going to find from 9 to 18. So it means I will use this expression. So let's try to do this one. And current situation, what we have, let me write it here. Okay, this connection I wrote here. And now, first of all, velocity is 0.2 and t minus 9 to power 2 plus 1.8. And integrate, students, what will happen? All of you familiar? S is equals to 0.2 and t minus 9 to power 2 plus 1.8, and integration 9 to 18. And what is the way? Increase the power by 1. I got a 3 by 3, and 1.8 become 1.8 t, and 9 to 118, sorry. So when I solve it, let's see what happens when I plug in 18. So in the numerator, let's see, it come 18 minus 9, and the power is 3, and divided by 3 and plus 1.8 times 218, and I'm getting 81. And when I plug in 9, then what happens to 9 minus 9? 0. So I get a 1.8 into 9, and I get it 1.8 into 9. I get it 81 over 5. So when I subtract, I get here, students, distance is coming with me from 9 till 18 is 64.8. And what is the connection between them, student? It is a 10 times. You can see that so clear. Distance from 0 to 9 is 10 times to, sorry, opposite I wrote. So it is a 1/10, sorry, 1/10. 1 over 10 times to distance from 9 till 18. So proved. So I hope so. The concept is Very clear, not a hard job. So let's go for, one more part. We have C, find the greatest acceleration of the particle during first 10 seconds. Okay, so you talk about first 10 seconds. Okay, what is the technique here? Because first 10 seconds you talk about, and this equation we use after 9. Okay, and so we have to use this equation. So let's try to use it. So this one, copy, and I paste here. What is the basic way, students? If I differentiate, students, what will happen? I will get acceleration. And power comes down and power 1 less. And this becomes 0. Acceleration becomes 0.4 times 2, t minus 9. Okay, what is the basic criteria, students? Because we need to find the maximum acceleration. Okay. At 9, students, at 9. So at 9, if I check it, at 9, I'm giving 0 acceleration because I will get a 0 answer. And after during the first 10 seconds, okay? Thing is that if I go for it, because what's the basic technique? Whenever we need a maximum acceleration, students, what I will do? I will differentiate acceleration equation. This is a way. When I differentiate, I will get what here? 1 minus 0. So 0.4 meter per second is a maximum, this dA over dt. Okay, this actually, I got it. And normally, what is the pattern? We put 0, but you can say that after that, no changes after. So 0.4 meter per second is coming after that. So even I plug in 9 here, I get at 9, I'm getting acceleration 0. But after 10, at 10, I'm getting answer becomes 0.4 meter per second. So the maximum acceleration which I can get it from here is 0.4 meter per second square. I hope so. The concept is very clear. And the question is question number 6. We have an elevator is pulled vertically upwards, okay, and by a cable. Okay, the elevator accelerates and this much for 5 seconds, and then constant speed, and then we have deceleration. And whenever these kind of questions come, I make a rough diagram. So this is a planning. So he said get a speed to find out. So we have to find out this speed also, highest, okay? And this is a sketch, and then, all right, I hope so the concept is clear. So let's try to do the question now, okay? First of all, I make a rough, not rough, sketch, okay? But when you do sketching, you must know some important things. The 5 seconds. So let's take a 5 here. And I make a point here. Okay. And obviously 25 seconds is a constant speed. 25. It means 25 plus 5, 35. So just make it here 25. 1, 2, 3, 4, and 5. So these are 5, 10, 25. So the 30 here. So again, 5 and 10. I think this is okay, or make it just some like this. Okay. Now, what is this thing? This is a velocity. And he said that acceleration is what? 0.4 for 5 seconds. And then constant means straight line. All right. Then it decelerates given by him. So what is the formula? I think we can do easily. What is the starting velocity here? U0. Ending velocity is task. Acceleration, how much? 0.4. And time, how much? 0.5. I think V is equal to U plus AT. Works easily. V is a task. U0, acceleration 0.4 into 5. 5 was a 20, so 2 meter per second. So it means this is a 2 meter per second. So I'm writing now 2 here. So I hope so all of you understood well how I got this 2. Now, students, what is the important part left here? We don't know where it ends. For that reason, we have to work on the last situation. And what is the last situation? Deceleration is negative 0.2. So let's see, it's ending here and ending here, ending here. I don't know where is ending. Okay. But whenever ending, last velocity is 0. So I say u is 2. How u2? Because this velocity 2, 2, 2, 2, 2, 2, 2. So u is 2 and last velocity confirms 0. Deceleration negative, I have to write must. Okay. And I'm looking for time. So v is equal to u plus at. V is 0, U is 2, and acceleration negative 0.2, and this one. So time turns to be 10 seconds. To cancel out, let me check, 0.2. Yeah, it's a 10 seconds. So 10 second means currently is a 30. So one small box I make for a 5. So it must join with that. So those are sketching, but you have to make it close to accurate. Okay, this is done. So Alhamdulillah Rabbil Alameen, and this gap is 25 from here till here. Okay, so this sketching part is done. Let's go for next part. Total distance traveled by the elevator. Distance traveled is a called distance, is an area of the underfloor. What does the trapezium formula have? Into h into a plus b. Okay, have h is this one 2. And A is this gap, A and B is this gap. So I think is 25 plus 40, 2 to cancel out, and I got a 65 meters. So I hope so. The total distance traveled is very, very clear, and we have done it. So let's go for next part. The mass of elevator is 1200 kilogram, and its crate is a mass of m kilogram resting on the floor. Okay, let's say this elevator. I try to show you this is a, though it is not easy to okay, just make a rough eye diagram. Okay, so this is just like an elevator, and a box is placed there, and this a box has a what is the mass of this box is crate. This is a m, so I can say 10m, and the and elevator is 1200. Elevator 1200, so this is a 1 2 and 000 because into 10, and this is a tension string upwards. Okay, and what is the situation we have, students, when the tension the cable of the tension cable is this much given, and he said decelerating, and decelerating we have already here with deceleration negative 0.2. So deceleration we have already. So it is a negative 0.2. So basically it's moving upwards. So what is the net formula we use? Net force is equals to MA. Because motion is upwards, so students, so how I write a formula? Formula start from tension. So I can say tension minus weight component. There are two weight components. One is a 10m and one is a 12,000. Okay, there's a weight, okay, and equal to mass into acceleration. And how much mass for the both? First mass is 1200, second mass is an m kilogram, and acceleration, deceleration we have already available. And what is that? Negative 0.2. Now it's just a matter of solving, and tension is what? 12250, negative 10m and negative 12,000. And here I got it. So I'm going to multiply. So 1200 times 2.2, and I'm getting here negative 6,000 and negative 0.2 m. So I bring 10m and this on this end, and 12250 minus 12000 and plus 6,000. So if I check it, 12250 minus 12000 and plus 6,000, and divided by what? On the other end, 6250. On the other end, I got 9.8 m. So if I divide 9.8, so my answer is turns to be wait a minute, let me check once again. Yes, student, one correction is there. This multiply with this. We're not getting that. If we're getting here, four, wait a minute, let me check, 240. So this is a 240 basically. So this is also 240. Okay, so we got here 240, we got here 240. And when I bring it on the other end, this becomes 490. and divided by this was my mass. I got it here 50 kilograms. So I hope so the concept is very clear. Let's talk about last part, finding greatest magnitude of the force exerted on the crate by the floor of the elevator and state its direction. So find greatest magnitude of the force exerted. Okay, so force exerted, it is only applicable. You see that when you're moving on the elevator, if you are decelerating, if it accelerating, you feel the weight is the force is less. The weight is less. Your weight decreases some, like you can guess. Okay, but he said here to find out the greatest magnitude of force exerted on the crate. So let's say there's a crate. Okay, and what is this? Is called 10. What is the mass? 50. So 50 into 10, 500 Newton. Okay, and what is this? R. Okay, and greatest magnitude of force exerted on the crate by the floor of the elevator. So it is placed on the elevator, and this is a okay, and state its direction. Because it's moving upward. So what is the situation we have, students? We can plan here because R net force is equals to MA. Again, same formula we use here. Okay, R minus 500 into mass is what, 50, and acceleration will use this acceleration. We'll use this acceleration 0.4. We'll not use negative 0.2. Okay, so we'll use 0.4 here. Okay, and when I use this one, so let me calculate, and it becomes 550 into 2.4 and plus 500. So I get it here. The R is becoming with us 520 newtons, and direction is naturally upwards. Okay, because it was moving upward. You know, in the beginning he mentioned here. In the beginning, mentioned the word vertically moving upwards in the cape. Okay, and it is moving upward with acceleration 0.4. So that is why. So I hope so. The concept to the question is very, very clear. Question number 7 we have now, and the rough slide. So it means XYZ. So it means throughout it is a rough. And he mentioned now this 2 meters you can see here, and this sine alpha is 0.28. Whenever sine alpha given, so we know it how to get the cos, because it's a rough, so cos is compulsory to get. And what formula? Cos square alpha is equal to 1 minus sine square alpha. If I want to find a root of 1 minus 0.28 to power 2, this value get from here. And when I type in calculator, so it's turned to be 0.96. 0.96. So I will use this value and I will use this value. Okay, this is done. Mass is given here 25 kilograms. Okay, read and write, very important. And start from rest, so velocity at x is equals to 0. And work done against a friction force is 50 joule from x to y, So from here till here. So you can say work done by frictional force is 50 joules. But do you know, students, it is it's sliding due to own weight, no extra force. Capital F is 0. In this sense, work done by applied force is 0 as well. So let's apply the magic formula. Work done by applied force, work done by friction force. I'm applying from x to y. And I'm dealing this like a ground level. This is like a ground level. So why is it? Okay. So kinetic energy plus potential, because partly coming from top to down. So we are ending point y and starting point x. So this is clear to you. This is magic formula I'm going to apply. This is obviously 0, but this is what formula? This is a value given by him fully. And what is kinetic energy at y? That is my speed to find it. I'm opening half mv square, mvy square. And potential energy, I have said before, that the ground level, so potential energy is 0 because height is 0. And the kinetic energy at x is 0 because speed is 0. Negative into positive, negative. And what is a potential energy formula? Basically, mass into gravity into height. There's a potential energy. So mass is 25, gravity is 10, height is a concern, and height from here to here is 1.8. Now, students, 25 into 10 into 1.8, I got 450 will go there. So 450 minus 50 is equals to what is basically, this is called kinetic energy. So I'm just, first of all, I'm writing kinetic energy at y, and that is a 400 joules. And now kinetic energy is basically equals to half into, or I do one thing. So I'm writing it now here. So kinetic energy at y. So what is the kinetic formula? Half mv square. mv, because I'm looking for the velocity at y, equal to 400 joules. So this 2 multiply 25, divide and take root of that. So 800 by 25. So I got a 32. And when I take a root of this, I get a velocity of y is 4 root 2 meter per second. Or in 3SF, it turns to be 5.66 meter per second. So you write any answer, no problem at all. So this is done, students. Let's talk about last part. It is given that child come to rest at z. So it means diagram, if I make it, so particle is stopping at z. So velocity at z is naturally 0. The energy method to find the coefficient of friction between yz. So yz means we will not care the above, we will care about yz. So yz, this triangle, I'm going to copy. yz, 2 meters, alpha, 90 degree. So this, I'm going to copy from here and bring it down. So this part is very clear now. So you know what is this y? This is a y. What is a kinetic energy at y? Kinetic energy at y is 400 joules. How come? You can see kinetic energy at y is 400 joules. You can use speed or use energy, no problem at all. Again, we use the magic formula, work done by applied force, work done by frictional force, kinetic energy plus potential energy at z, which ending, minus kinetic energy at starting, I mean y. So this is 0 because it is coming itself. And this formula basically force into distance. And kinetic energy z, because he said velocity 0. So this gone. And potential energy z is because height is 0. Height is 0. So mgh also 0. Kinetic energy of y, I have 400. Negative into positive, negative. And potential energy is, what is mass formula? Mgh. Mgh. Mass this. And height is this. This I want to find. How to find height? Opposite by hypotenuse. Sine alpha. So this turned to be this, and sine alpha we can see from top 0.28. So 0.28. So this turned to be basically height is 0.56. So this is now I can write. I'm writing it now here. Mgh, mass 25, g and h 0.56. So 400 and plus 25 into 10 into 0.56. So this is becoming negative 540. this negative friction into distance, negative, negative cancel. And what is this distance? 2 meters. So I'm writing here 2 meters. 2 meter will go down and friction value is coming with us divided by 2, so 270 newtons. What is F mu R? And what is R? You know it very well. I'll bring on the right hand side what's R value when a particle is inclined plane. And this is alpha angle. This is R and this is mg cos alpha. M is 25, G is 10, and cos alpha we have a value which is 0.96. 0.96. And I'm copying here 0.96. So I hope so up till here very clear, and my answer is coming finally 9/8. And I hope so the concept is very clear how I got it, and question paper is completely over. Best of luck for your exams, and pray for me, and I'll pray for you. And the question you've done wrong, please redo after class, after watching this video. Assalamu alaikum wa rahmatullahi wa barakatuh.